Hello, and today we're going to talk a little bit about cell diagrams, or sometimes called line diagrams. And the whole point of a cell diagram is to come up with a quick, easy way to represent a electrochemical cell without having to draw the whole thing. But to begin with, let's go ahead and look at the whole thing. So here we have a galvanic cell where we have a zinc electrode in a zinc sulfate solution, where it's attached with a wire going through a voltmeter, going down through a copper electrode into a copper sulfate solution, and both of our aqueous solutions are connected with a salt bridge. Now, when drawing a cell diagram, one of the first things you have to do is you have to figure out where your electrons are coming from and where they're going. So I will cover this in a different video on how to determine where the electrons are coming from. But our zinc is going to be generating electrons, and it's going to be breaking up into zinc 2+. And so it's going to be generating electrons, and those are going to be traveling through the wire, through the voltmeter, back down through the wire into our copper electrode or cathode, and then ultimately it's going to be interacting with our copper 2+ to generate some more copper solid to plate onto our cathode. So when drawing the cell diagram, we have the electrons traveling one way. But when we're drawing our cell diagram, we want to start where the electrons are being generated and go the opposite direction. We're going to be following the path of the ions as they essentially meet up with where the electrons are coming from. So the first thing we're going to do is write down where our electrons are coming from. In this case, it's going to be the anode, or zinc solid. Then, when we come from our zinc, we are coming into contact with our zinc sulfate. So since we're going from a solid to a liquid, this aqueous solution being a liquid, we need to represent that with a single bar. And this is just representing that we have a barrier that is forming between two phases. Then, from our zinc sulfate, we're going to travel up through the salt bridge. So we're going to put down zinc sulfate, and then to represent the salt bridge, we're going to put a double bar. And basically what a double bar represents is simply the salt bridge. So then after we come up through the salt bridge, we are going to be interacting with the copper sulfate. And so we'll put that down. And then from the copper sulfate, we'll be plating our solid copper onto whatever cathode this is. In this case, it happens to be copper, but it could be any inert electrode. But we are undergoing a phase change. So since we're going from a liquid to a solid, we'll put another single bar. And then in this case, we are going to put down copper because that is in fact the cathode we're using. But this could be, like I said, anything that's inert to copper sulfate, such as platinum or carbon, really pretty much anything. If we put something in there that does react with copper sulfate, it could still work, but we'd have some side reactions and it would mess up our cell potentials. But this is basically how you draw a cell diagram. So again, we're just following the path opposite of the electrons and doing the path of where the ions can travel. Now there's a couple other ways to draw other cell diagrams. So we could make this more generalized to where we can just put in our zinc solid going to zinc 2+, because we don't really care what other ion is on our zinc 2+. The SO4 2- doesn't really do anything. It just stays dissolved in aqueous form. And same thing with our copper 2+. We don't care where the copper 2+ is coming from. It could be something like copper nitrate. It doesn't have to be copper sulfate. We just need something that gives us copper 2+. And another way we could draw our cell diagram is to be a little bit more descriptive, in case someone wanted to know exactly what experiment we were doing. So in this case, we could include something such as our molarities. So we have our zinc going into a 1 molar zinc sulfate solution, and then through a salt bridge to a 1 molar copper sulfate solution, and finally to our cathode, our copper solid. So all three of these are very legitimate ways to draw a cell diagram. Sometimes it's nice to have it be a little bit more ambiguous, so it's a little bit more versatile. But sometimes it's really nice to have the full-on description of what's going on. So all three of these ways are very good ways to draw cell diagrams, and I hope you found this useful, and I look forward to seeing you in the next video.